this video, we're going to talk about authenticating real images and videos out of cameras to make sure they're not AI with OpenOrigins. Real quick, you're watching VP Land. Special thanks to our sponsors, Blackmagic, View, and LucidLink for helping make our NAB coverage possible. And now, back to the video. All right, so Manny, tell me about OpenOrigins.
Sure. So OpenOrigins is a content authenticity platform. We have the world's most scalable blockchain for ingesting petabytes of content. We've got tooling for authenticating content at the point of capture. So we've got applications for iOS, Android, DSLR cameras that authenticate the photos as they're being taken, make sure they haven't been edited, that they were taken at the time and place they say they were. And all of that proof information then gets anchored to a blockchain so that anyone can independently verify it. We also have tooling for historical content, so we work with large video archives. We've secured the second largest news video archive in the UK. So we work with them, we go into those archives, do a security audit, and run scripts that prove that synthetic content hasn't already polluted that archive. Once we have confidence in that, we take all of that proof information for every file in this historical archive and put that on the blockchain as well.
Okay, so that's sort of like, well, first off, the first part is you can kind of add a verification so like that we know something was actually shot in real life with a phone and not altered. And then the archive bit was about, so verifying like the archive is legit, and then when that material goes out in the future, then it can be verified again that that archival material was not
and also
altered.
if that content then gets used in derivative works, right? So you've got a longer clip, gets chopped up, gets used in something else. Or if someone, I don't know, takes my footage and makes it into a deepfake, puts someone else's face on it, we've got reverse image lookup functionality on our blockchain. So if I take an edited version of the footage that was posted, we'll be able to find, oh, this is 88% similar to an authentic image reported by the BBC. These pixels in the middle seem suspicious.
So yeah, what do you want to show?
I'll show you
how this works on the app.
I'll do a quick demo of the iOS secure sourcing app. So this is how we can authenticate content at the point of capture using an iOS device. So this is our open source secure sourcing application. Here we can prove content as it's being captured on an iOS device. So what I'll do is I will take a selfie. You want to join in?
Sure, let's go.
So as I took that photo, the software first authenticated that it's running on a real iPhone and not an emulation. It authenticated the location, it authenticated the time, and it created this 3D depth map. Right. So, and this is important because
so this is sort of like the signature of the image.
No, it's actually the depth of the scene, right? So you can see our faces have curvature. We're standing in front of this purple wall. And this is important because if we didn't have this depth information, the way you could cheat the system is you could take a photo, edit it, put it on a screen, and then take a photo of the screen. But a screen is going to appear flat, whereas our faces have curvature. We take that information, we post it, it verifies the metadata, and anchors all of that to the blockchain. And now,
so can you also give a blockchain primer? And also, is this doing anything to the actual image file itself, or is it just like the blockchain's getting to copy the information?
The blockchain doesn't even see the image, right? So the whole infrastructure is designed in such a way that the data should never exfiltrate your infrastructure, right? So you can imagine that this gets embedded into an insurance app. The insurance provider doesn't want us to have a copy of an insurance claim because that's very personally identifiable information, sensitive information. So the image goes to their servers. The proof information we collected at the point of capture is cryptographically tied to the image, and that's the only thing we see. We can't reverse engineer the image from that, but we can prove that the image was authentically taken at that point. Right. So the proof information would look something like this. You've got the device that was used, the timestamp when it was created locally, when it got to the blockchain, the location,
blockchain info,
and all the blockchain info. And this blockchain information is obviously publicly verifiable. Anyone can go in and validate it, and anyone can build applications on top. Right? So if you are interested in creating some sort of a data licensing model, well, we've got all of the proof information there. You know where you can find that content. Use the platform as you see fit.
Now, this is on an iPhone, and obviously we can kind of have more control over that. What would it take for a camera manufacturer or something else that images shot on Canon, Blackmagic, Sony to verify?
We've done validation with Canon and Nikon so far, but I would imagine we can make it work with anything as long as there's a way to connect it to an iPhone or an Android device. So usually it's either over a Wi-Fi or via USB cable. then the mobile acts as an intermediary root of trust.
Oh, okay, and so that could work with an existing camera? It doesn't have to be like a special camera with this built in?
I think with the Nikons, we could validate that any camera in the last 10 years that's Wi-Fi enabled, which is almost all of them, can work with this.
Cool. How important do you think this is going to be in the future now, especially with generative AI and deepfakes and everything else happening?
The analogy I like to use is like in the Industrial Revolution, when it started, we used to build factories and coal power plants in the middle of cities. Wasn't good for our lungs. We stopped doing that. We said machines and their pollution go away. Humans live on the other side. We got to do the same thing with content. We're in the middle of our AI industrial revolution, and we're building the factories in the middle of where humans live. And so we can't tell between the polluted synthetic versions and the real versions. We're here to create that firewall.
Yeah. Great. Well, thanks so much, man. Appreciate it.
Nice talking to you.
Yeah. That's it for this video. Thanks for watching. And thanks again to our sponsors for helping make our NAB coverage possible. For all of our videos on NAB, check out our playlist right here. And I'll catch you in the next episode.